In previous lecture, I discussed what is relation, how many relations possible, what is inverse relation, what is complement of relation. Today I will discuss properties of relation. Before that, what is diagonal relation. A relation R on a set A is called diagonal relation on A if R equals to A for all A belongs to A. Suppose a set contain 1, 2, 3, then diagonal relation will contain 1, 1, 2, 2, 3, 3. Diagonal we can represent by this triangle symbol. Now properties of relation. First properties is reflexive relation. So definition 3, it's about reflexive. A relation R on a set A is called reflexive if A belongs to R for all A belongs to A. This A is for set A, this A is for element A, or you can say members of that set A. So one relation will be reflexive if it contains a relation to itself. And here diagonal relation is the smallest reflexive relation. And any superset of diagonal relation is also reflexive. Means it contains the diagonal relation plus any other order pair that will be also reflexive. Let's A equal to A, B, C. Now some relations. R1 contain A, B, B, C, C. This is the diagonal relation and it is the smallest reflexive relation. Just remember, empty set is not reflexive. Like phi is not reflexive. Smallest reflexive relation is the diagonal relation, that is A, B, B, C, C when A contain A, B, C. Now R2 contain A, B, 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 C, A, C, C. This is also reflexive as it contain A, B, B, C, C. So any superset of diagonal relation is also reflexive. That's why R2 is also reflexive. Next R3. R3 contain A Cartesian product A, and that is our largest reflexive relation. So smallest reflexive relation is the diagonal relation and largest one is A Cartesian product A. Now number of reflexive relations possible. So how many relations possible? If A cardinality equals to n, then number of relations possible equals to 2 power n square. I already discussed this in previous lecture. Now from that 2 power n square, how many relations are reflexive? So consider a set A with n element. Let A contain 1, 2, n minus 1, n. Now A Cartesian product A, it contain n square element. Now from that n square, n element is minimum. Means 1, 1, 2, 2, n. So these order pair are minimum. That is compulsory for a set to become reflexive, the diagonal relation. So from that n square, n order pair are minimum. So we have n square minus n choice to fill the rest. So there will be 2 power n square minus n reflexive relations possible. This thing you can write 2 power n multiplication n minus 1. I just took n as common. So number of reflexive relation possible equals to 2 power n multiplication n minus 1. Now number of relations which are not reflexive. This is number of relations which are reflexive. Now number of relations which are not reflexive. So total relation is 2 power n square minus 2 power n square minus n. That will be number of relations which are not reflexive. So total number of relation minus reflexive relation, that will be for not reflexive. Just remember this, number of relations possible is 2 power n square. Number of reflexive relation possible equals to 2 power n square minus n. Let's see some example of reflexive relation. Example 5. Consider the following relation on 1, 2, 3, 4. Some relations are given and we need to find which one is reflexive. Now what will be diagonal relation on this? It will be 1, 1, then 2, 2, then 3, 3, then 4, 4. And minimum reflexive relation is this. 1, 1, 2, 2, 3, 3, 4, 4. And any superset of that will be also reflexive. Now check its relation whether it contains this diagonal relation or not. So R1 contain 1, 1, 2, 2, then 4, 4. It doesn't contain 3, 3. So this is not reflexive. Next R2, it contain 1, 1, no 2, 2, 3, 3 or 4, 4. So not reflexive. Next R3, it contain 1, 1, 2, 2, 3, 3, 4, 4. Yes, it contain all the diagonal order pair. So it is reflexive. Next R4, it doesn't contain 1, 1. It doesn't contain any diagonal pair, neither 1, 1, nor 2, 2, nor 3, 3, nor 4, 4. So not reflexive. Now R5, it contains 1, 1, then 2, 2, 3, 3, 4, 4. It contains all the diagonal order pair, hence it is reflexive. R6, 3, 4, it is not diagonal pair, so not reflexive. We found R3 and R5 are reflexive, whereas R1, R2, R4 and R6 are not reflexive as it doesn't contain the all diagonal pair. Next example 6. Consider this relation and the set of integer R1 a b a less than equals to b, R2 a b a greater than b, R3 a b a equals to b or a equals to minus b, R4 a b a equals to b, R5 a b equals to b plus 1, R6 a b a plus b less than equals to 3. Which of these relations are reflexive? Means which of these relation contain a that we need to check. Now R1 a less than equals to b. So a can be less than equals to a. 3 can be less than equals to 3. Hence it is reflexive. As there is a equals to also, that's why it is reflexive. Next R2 a greater than b. Is a greater than a? No. Is 3 greater than 3? No. So any number cannot be greater than itself. Hence R2 is not reflexive. Now R3 AB says that A equals to B or A equals to minus B. A equals to A. Yes, 3 equals to 3. 5 equals to 5. Yes, this is reflexive. R4 AB equals to B. This is reflexive. A can be equals to A. Next R5 AB equals to B plus 1. This is not reflexive. 3 equals to 2 plus 1. So 3 and 2 will be order pair. In case of reflexive, A, S should be order pair. Here these are different numbers, so this is not reflexive. Next R6 A plus B less than equals to 3. Like 1 plus 2 less than equals to 3. So 1, 2, are they both are same? No. So R6 is not reflexive. We found R1, R3 and R4 are reflexive. Rest R2, R5 and R6 are not reflexive. In today's lecture, I discussed what is reflexive relation, how many reflexive relations possible, and how to identify a relation is reflexive. In next lecture, I will discuss irreflexive relation and symmetric relation. If today's lecture is helpful for you, please like, share, and subscribe. Thank you.